Okay, continuing with section 5.1, solving inequalities. Phrases for inequalities. This is where y'all need to make sure you remember some of these phrases. And if you can't remember what something looks like, what something stands for, go back and look at this chart. Less than would also, another word for less than would be fewer than, or greater than, or more than would be greater than. The common one that you will see in the book a lot, that a lot of people mess up as, is with at most. At most is a less than or equal to symbol. And then for the greater than, a common would be at least. Notice I highlighted those two because those you're going to see a lot, and those are the ones that people always tend to they can't remember which one that goes to. So remember, at most is what? Less than or equal to. At least is greater than or equal to. Okay, example 4A. Felix needs for the temperature of his leopard gecko's basking spot to be at least 82 degrees Fahrenheit. Currently, the basking spot is 62.5 degrees Fahrenheit. How much warmer does the basking spot need to be? Okay, how would we write this? First, right now, it's at 62 degrees. Or 62.5. So it's at 62.5. And we need to increase it to some amount. Do we know what we need to increase it by? No, so we're going to give it X. And it needs to be at least 82 degrees. Now, if you can't remember what at least stands for, go back and look at your chart. At least stands for what? Greater than or equal to. So we're going to put greater than or equal to 82. So there's the equation, and then to solve, we would subtract 62.5 from both sides. Now make sure you add a decimal and a 0 at 82. Remember, when you're adding or subtracting decimals, you line them up. So that would be 9.5. Or excuse me, 19.5. Now, anytime you have a word problem, you must put the answer in some type of word problem. I don't make you write it in a complete sentence, but I do want you to use a phrase. Do y'all know the difference between a sentence and a phrase? And what I would recommend you doing when you write the phrase is use the exact same word that they used in the problem. So we need to raise the basking spot to be at least, we need to raise the basking spot to be at least, or we need not to be, sorry, we need to raise the basking spot at least 19.5 degrees. So when I go to grade your paper, I am going to make sure that you have that word. If you have raised the basking spot to be, raise the basking spot 19.5 degrees, I'm going to mark it wrong. Because you're saying it has to be 19.5. It does not have to be 19.5. It can be greater than 19.5. Okay? Read example 4B and you come up with the equation and solve it. Okay, you could have done it one of two ways. 18 for the belt or the t-shirt plus 14 for the belt, and he has $65 to spend. So what is he going to spend on the jeans? We don't know. Now, can he spend less than $65? Can he spend exactly $65? Yeah. He just can't spend more than $65. So what would our inequality symbol be? Less than or equal to 65. Or you could have added 18 and 14 together to get 32, plus x is less than or equal to 65. So you could have had the equation like this or like this. It really did not matter to me. And then to solve, we would subtract 32 on both sides. And get x is less than or equal to 33. Are we finished? No, we need to write our sentence. What would our sentence be? He can spend, you could say at most $33 on jeans, or we could have said no more than, or different words. They didn't really have a word in the problem, so we had to come up with our own. Okay, any questions on that? Okay, section 5.2 is solving inequalities by multiplication and division. If you multiply or divide both sides by a negative number, you flip the inequality. So copy that sentence down, box that sentence, star that sentence, memorize that sentence, and then copy these 4 examples down, and then we'll do each one. Okay, number 1, we're going to divide both sides by 2. Did we divide both sides by a negative number? No, so we do not flip the symbol. So that's x is greater than 2. On number 2, negative 2x is greater than 4. To solve, we divide both sides by a negative 2. So here, did we divide both sides by a negative number? Yes, so we flip the inequality, meaning it's a greater than, we flip it to make it a less than. And 4 divided by negative 2 is a negative 2. Okay? So make sure you flip. Does everybody understand why we had to flip that? Number 3, 2x is greater than negative 4. We divide both sides by 2. Did we divide both sides by a negative number? No. So we do not flip the inequality. So x is greater than or equal to negative 2. And number 4, we divide both sides by a negative 2. Did we divide by a negative number? Yes. Do we flip it? Yes. And negative 4 divided by negative 2 is a positive 2. So it doesn't matter what the answer is. What matters is if you divided both sides by a negative number. Oh, skip that. I don't feel like singing today. Okay, example 1A. Of the students surveyed at Madison High School, fewer than 84 said they had never purchased an item online. This is about 1/8 of these surveyed. How many students were surveyed? Okay, of the students surveyed at Madison High School, fewer than 84 said they had never purchased an item. Fewer. What inequality symbol stands for fewer? If you can't remember, go back and look at your chart. Fewer is what? Less than. So it's going to be less than 84. Now this is, what stands for equal. In this case, we wouldn't use an equal sign, we're going to use a less than sign. 1/8 of these surveyed. Well, how many people were surveyed? We don't know. X. So, but 1/8 was surveyed. So how would we write that? 1/8 x. There is the equation. And then let's refresh our memory on solving fractions. What do we do to solve for a variable that has a fraction? Multiply both sides by the reciprocal of 1/8. What is the reciprocal of 1/8? 8/1, or could we just say 8? Yes. And if you have a calculator, great. If not, you can go to the side and multiply. 8 times 84 is 672. Now, let's just refresh our memory about set builder notation. Remember we talked about we need to be familiar with set builder notation. You will not have to write your answers for your homework in set builder notation, but you do need to know what that means. Set builder notation is the braces x such that x is less than 672. I am okay with you leaving the answer just like that. Now, I didn't say anything about graphing, but let's go ahead and graph this because you will have to graph a few of your homework problems. Because these numbers are so big, I'm not going to have as much, many on the number line. Are we going to have an open or a closed circle? Open circle at 672, and it's all numbers that go to the left. Example 1b. Read it, come up with the equation, and solve it. Mount Kinabalu in Malaysia has the greatest concentration of wild orchids on Earth. It contains more than 750 species, or about 1/4 of all orchid species in Malaysia. How many orchid species are there in Malaysia? Okay, more than 750. How would we write that? Greater than 750, which is the same thing, about 1/4. Do we know how many species? No, so that's 1/4 x. So that is the equation. Now to solve, we would multiply both sides by 4. And 750 times 4 is 3,000. Are we finished? No, we need to put in a sentence. Now what word are we going to use in our, what phrase are we going to use? More than. There are more than 3,000 species in Malaysia. Example 2a, negative 3/7 r is less than 21. Okay, when we have a fraction, let's refresh our memory. When we have a fraction, we have to multiply both sides of the equation by the reciprocal. What is the reciprocal of negative 3/7? Negative 7/3. So we're going to turn that 21 into over 1 times negative 7/3. So on the left side, everything cancels. Now, did I multiply both sides by a negative number? Yes, and if you multiply or divide both sides by a negative number, you flip the symbol. So that becomes a greater than. And then what am I going to do over here? I'm going to cross reduce. 3 goes in 3 one time, 3 goes in 21 7 times. So 7 times negative 7 is a negative 49. Now we're not going to put in set builder notation, but let's refresh our memory on graphing. Open circle at negative 49, and this stands for r is greater than. So which numbers are greater than negative 49? All the numbers to the right. Example 2b, negative n over 6 is less than or equal to 8. We have to get n by itself. So we have to multiply both sides by a negative 6. I'm gonna put that negative, think of that negative as being with the 6, because I need to get rid of the negative and I need to get rid of the 6, so I'm gonna multiply both sides by what? Negative 6. And when you multiply both sides by a negative number, you flip the symbol and get negative 48. Okay, we're going to divide by 60 on both sides. Now, 60 doesn't go into 8 evenly. Do I get a calculator out and give it a decimal? Calculate a decimal? Absolutely not. I need to reduce this. What goes into 60 that also goes into 8? 4. 8 divided by 4 is 2. And 60 divided by 4 is what? 15. X is greater than 2/15. Now, if I had to graph this, how would I draw my number line? 2/15 is between what two numbers? 0 and 1. So the denominator tells you how many little slashes you're going to count by. Okay, so each little slash is going to be 1/15. So this is 1/15, 2/15, 3/15, 4/15, 5/15, 6/15, 7/15, 8/15, 9/15, 10/15, 11/15, 12/15, 13/15, 14/15, and 15/15. And what is 15 over 15? It's the same thing as 1. So when you have a number line in a fraction, you can just go from 0 to 1. Okay? And 2/15 is, and you don't have to label every single one. And they're little slashes too. So here's 2/15. So we're going to have an open circle at 2/15 and it goes to the right. All right, example B, where you divide both sides by a -7. We divided both sides by a negative number, so we flip it and become greater than or equal to. Now, I'm thinking 147 divided by 7. Yes. 7 goes into 147 evenly 21 times, so the answer is -21. Graph it. Close circle, and it goes to the right. Okay, example C, we're going to divide both sides by 6. So -42 divided by 6 is a -7 is greater than R. Now, remember what I talked about the other day. When you're dealing with inequalities, the variable always has to be written on the left side. So we have to rewrite this and flip it around to say R is greater than -7. And if I asked you to graph it, yeah, I got to flip it around. The inequality is pointing to R. Flip it. Thank you. So then it's going to be an open circle at -7, and it goes to the left. In example D, -1/2 n is less than 6. We're going to multiply both sides by the reciprocal, which is be a -2. And because we multiplied both sides by a negative number, we flip it and get -12. Okay, that is the end of section 5.1 and 5.2.